Hello everyone. Welcome to Algebra 2 homework 1.1 expressions and formulas. Primarily, we're just going through a couple graphs, making sure that we understand the difference between domain and range, determining whether something's a function. Some pretty straightforward stuff there. First off, again, this is a relation, just a set of ordered pairs that we'll be working with here. I'm just going to start plugging them in on the graph. We've got 2, 3. We've got 1, 3. -1, 3. And -2, 3. Let's figure out what the domain of this guy is. Let's see. This is all the first numbers here, so let me actually switch to a different color here. We can highlight them. We've got 2, 1, -1, -2, and that's it. So we've got, let's see, 2, 1, -1, -2. And that's it. What about range? Well, uh, that's 3. That's it. That's the entire range of this function would be 3. Um, yeah, pretty straightforward there. Nothing else is in the second position there, or the y coordinate. Is this a function though? Technically, yeah. No one input is paired with more than one output, or any one element in the domain is not paired with more than one element in the range. They're all paired to the same element in the range, but no element in the range is paired with the same in the domain. What about this one here? Number 2, we've got 1, 1. We've got -1, 1. We've got 1, -1. -1, -1, and 0, 0. Okay, pretty symmetric there. We've got, let's see, a domain of, this is all the different options that we have in that first position, or the input, the dependent there. We've got 1, 0, and -1. What about the range? That's actually the same as well here. We've got 1, 0, and -1. Is this a function? No, it does not pass the vertical line test. Right here, it passes through 2, and right here it passes through 2. And remember, that just means that there's one element, or at least one element, in the range that is paired, I'm sorry, one element in the domain that is paired with more than one element in the range. This 1 can go to -1 or 1, and this -1 can actually go to 1 or -1. So it fails in 2 ways. Let's see, let's move on. This is going to look a little bit more familiar to you. We've got y equals 3x plus 5. Some of you may recognize this is sometimes known as the slope-intercept form, and I'm going to use that to graph this just a little bit quicker. So the intercept for this would be 5, and the slope for this would be 3. So that means one change in y over change of x, and we'll go into more depth of that here in a little while. That essentially means that it's going to be a steep graph, that for every 1 it moves to the right, it'll move 3 up. That's what this is going to look like here. Domain for this, with most lines like this, it's going to be all real numbers. What about the range? That's also the same, all real numbers. Is this a function? Yes, it is. Definitely passes the vertical line test, and because the slope does not change, we know that it's going to keep on passing that. Now, what about the domain, I'm sorry, not the domain, number 4 here, x equals 5? Well, um, that pretty much explains the entire graph to us. If we go over to 5 right here, it's just going to be a vertical line right here. That's it. The domain for this one can actually be kind of tricky. This can mix a couple folks up. So regardless of what we put in for x, we're going to get 5 out. What does that really mean? Remember, domain are our x values, all of the sets of ordered pairs that we can come up with this. So you might think, well, regardless of what we plug in for x, we'll get 5. So that means the domain is anything and the range is 5. That would actually be slightly incorrect. What we're looking at here is the set of ordered pairs that we can get out of this expression. So one of the sets that we could get, one ordered pair that I can think of is just 5, 5. 5, 0. We've got 5, -2. We can do anything really, but that first number is always of 5. And that first number is our domain. That's our x value. And so that's what our domain is. Our domain is 5. What about the range? There's no restriction on what this could be, so our range is all real numbers. What about, is this a function? No. It definitely passes, it definitely fails that vertical line test. Definitely fails it. Let's see. This is one that some of you may need to grab your graphing calculator for. It's I don't know why, it's kind of a personal favorite of mine. I just think it's very, very interesting. There's a lot of really cool math that goes on in this specific function. Maybe I just gave it away. It is a function. But it will get really, really close to 0, but never quite pass it, and then shoot off towards negative infinity if we're looking at it from that direction. Then it, once it doesn't hit 0, kind of interestingly enough, comes back in and then zooms down just like that. The most common ordered pairs in this are 1, 1 and negative 1, negative 1. That's, of course, the 1 over x graph. And I talked about this a little bit in the cohort A, at least. The domain for this function would be all real numbers not equal to 0. And that's the same range as well, all real numbers not equal to 0. Is it a function? Yes, it is. For all elements in the domain, they're paired with exactly one element in the range. If you guys have any questions about this, or if you are curious about the kind of weird math surrounding this this function here, the 1 over x, I just find it fascinating. Talk to us in class. We'll be more than happy to talk to you about it and answer any questions you have. See you there.